Okay, so model is ready to run. The only change I've done was change in the stiffness of the slab. I changed it back to 0.35. The reason I've done this is because if you keep the stiffness of the slab to very small amount, the deformation of a slab in all load combinations would be very excessive, and it actually doesn't allow you to see the displacement of other elements and see what exactly going on. So I changed this slab just to 0.35, and now we run the model and see what is the result. Okay, the model is run. Now we can check the displacement. One is just simply visually coming here, and you can select one of your combinations. For example, you can go for envelope. If you want to see the maximum, you can check envelope S, or you can go for example, earthquake or wind. So let's check envelope S, which gives us the maximum displacement. So here we have just 1 millimeter movement. So it gives you maximum mean, so you need to see which one governs. So if I go upper levels, I can see the maximum displacement, but it doesn't give you any pattern or any indication. It just shows you the maximum. So if I want to check something like a pattern, I can go to, for example, Compass EQX1, and apply this. Then coming to the first level, so this is foundation. Even here you may have a little bit movement. The reason is the spring stiffness you have. You don't have a rigid stiffness. You see you have 1.3 millimeter even lateral movement here. So then you're coming in this level, it gives you 1.3. That means the walls are very stiff. So the movement at the foundation level was due to lateral spring stiffness, but here is a combination of lateral spring stiffness and the wall stiffness. Because the wall is very stiff, it doesn't literally allow for any movement. So you see the same number, 1.3 and 1.22, so a little bit movement one side. And then let's go to the other levels. So here is just 3 millimeter between these two levels, which is almost height to 1000, which is pretty good. Here again 3 millimeters. So here 9 millimeters, just 2 millimeters. So this is the total displacement you have. You need to calculate the drift yourself. So table output in SAP is not as good as ETABS. So if I come here to show table, in analysis result and structural output, for example, you cannot see a story drift. So you have model analysis, you have base reactions, and you have some other informations. And also in element output, you have about frame, area, output, and object and elements again. But it doesn't give you the story drift. It gives you joint displacement, which is too many joints, so it's very hard to track them, and those are very basic information. So we don't have information about the story drift, for example, here. That's why we need to check it level by level. If I come here and I want to check, for example, displacement due to wind for upper level, I can come here. You can prepare some combinations based on your need. You may have just combination for wind loads, and you can use that one and see what's the maximum movement due to wind load you have. So if I start animation, you see the structure is moving up and down more than the other side. The reason is it's a combination of gravity load and wind load, and you just applied wind load above. So how we can see that? We can come here and just choose wind X as a load case, then you have a better figure. So I'm coming here, wind XP, and apply. Yes, because you have side wind, you have windward and leeward, and also you have roof. That's why it's like this. So still you see other loads govern, so you cannot see wind load in X direction. Is a combination of other wind loads, but you can see the movement as well to this way. So you can just check the maximum and check the story drift. You need to ensure your lateral stiffness is sufficient. So if you see the drift is too much, if you see you have some unexpected deflection, for serviceability purposes, you need to change the size of the element. You need to increase the stiffness, regardless of the strength requirement. So this is the basic things we need to do. We need to check the global stability of the structure. We need to check the displacement. If everything is okay, then we can go for the detailed design and see from a strength point of view if the elements are okay or not. So I'm checking soil pressure for you guys for sizing foundation. I'm coming here and here on the form shape, and then I moved on to the foundation. So for size the foundation, if you remember, we have two foundations on area spring, which is pad footing. The rest are pile foundation and pile caps. So when I want to check those, I'm coming here, checking the soil pressure. I need to use working stress for soil pressure. So I can come here and go for envelope W and say I want to see the soil pressure, and then apply. Let's zoom in a little bit. Okay, so these are the area that I have soil pressure up to 455 E minus 3. Okay, because the unit is Newton and millimeter, I need to change it to kilonewton and meter, which is kPa. And now I have 455 kPa maximum here. If I right click here, it shows me this, and I can move and see what's the maximum. So you see 450 is here. I need to check my soil bearing capacity and see if this is acceptable or not. So this is maximum. If I check envelope minimum, it gives me more, because this is the reaction. So if I come here now, I have near 640. So I need to check envelope minimum for foundation to get the correct result. These are 0, as you see, because there is no spring stiffness. We need to check the pile load here. So we have 650. We need to see what bearing capacity we have, what type of soil we have. If, for example, the bearing capacity here is 700 kPa and we have 650, then it's all good. If sometimes you may have a little bit local overstress due to bending or something, there are some regulations in different standards that you can accept up to a certain percentage more than the bearing capacity, provided that the average of the bearing, the soil pressure is less than the bearing capacity. So could be, for example, 20 or 25% more one side, but the average of the soil pressure should be less than the allowable soil bearing capacity. So this is how you can size the foundation. So you need to see if this is okay, then fine. If not, you need to increase the size. So I assume, for example, 700 kPa capacity here, so if my foundations are correct. Now I need to check the piles. To check the piles, I can simply go down and check the base reaction, or I can check the axial forces on the pile. So I'm coming here, going to zoom all, and then I moved on to the base. So here is my pile toe level. So I can come here, go to joints, and I want to see joint reaction. So I can come again to envelope W and apply. So I can tabulate it, which is more readable. Then I can come closer and see the reactions. So the reactions are roughly 1200 kilonewton, for example, here, and 1260, 1170. Can I change the size of the text? Yes, I need to come to options, go to dimension and tolerances, and here I can change the font size. So currently the minimum font size is 5. I can change it to 7 and change this one to 10 and press OK. Now I can see them easier. So you see the pile reactions are something around 1300 kilonewton. So this is working stress. I need to see what is the end bearing capacity of the pile at that certain founding level where the pile is founded, and also what's the socket length and what's the skin friction of the pile, and the combination of these two gives me the capacity of the pile. So if the capacity of the pile is something around 1300 kilonewton, I would say these piles are okay. Otherwise, I have two options: either increase the diameter of the pile to give me a better bearing capacity, or increase the depth of the pile to have a socket length in a strong rock or soil to give me more skin friction, or increasing the number of the pile. It really back to the difference between the allowable bearing capacity and the load I have, how much I need to increase it. Is that a little bit or is that too much? Sometimes I need to add more piles to meet the requirement. Just we need to bear in mind about the space between the piles shouldn't be less than 3 times of the diameter of the pile. Otherwise, the area which is under pressure, those bubbles are interacting each other, and that will decrease the end bearing capacity of the pile. So they should have reasonably far from each other, which is the recommended number is 3 times of the diameter of the pile. So for 600 pile is minimum 1.8 meters center to center. So based on that, you can ensure that the end bearing capacity wouldn't be decreased because of the low distance between piles. Okay guys, so this is how you can preliminary check the structure and ensure that the size of the elements are correct, and you don't need to add any more element, you don't need to add the strength of the elements, or you don't need to add the size of the element. And then that's the time that you can say the model is ready to check and ready to design. One more thing is how to capture a picture to plot the, for example, stresses. So if I come here and for example I want to check the moment or the shear, so I can come here in shell and say for example M11. So just for clarity I can remove the joints, so invisible. Okay, now I want to plot this as a part of my report. So I need to come to here, go to capture picture. There are a few options here: either entire screen, that means the whole screen I have here; main window, that is the main window of the SAP; or I can choose current window. Currently this window is activate. Current window with title bar and current window without title bar. I choose this one and mention okay what name you want to put. I can put for example level 3 M22 or level 3 slab M22, and then it said okay this is based on JPEG format. I can save it. Model is coming to the address you saved. So currently I saved it in the main folder. So if I come here and open this, I can see this one. So this is one of the ways that you can capture a picture and show the plot of the contour for any internal forces you want to add into your report. And there are some other options that you guys can check, for example entire screen or without title bar. So let's see, when we choose main window what will happen. So here I put here main, and then I'll back again and check this one, and this is what it gives me. So you see this is not fully actually covered the whole window. You need to check the graphic and see what's been missed and how you can set it up. But current window generally is very reliable and you can easily use that one. Generally you want to see one. If you need two, you can just edit it by any PDF editor or any image editor in your Word file and add them next together. Ensure about the units, ensure everything is based on what you want, and then you can take the snapshot and then add it to your report. Okay, so this is what I want to show you for preparing the model and complete the analysis and ensure the basic result about deflections, about lateral stability, and about soil bearing capacity is correct. So we don't need to resize any element for serviceability point of view or for the soil bearing limitations. And now is the time that we can say sections are correct and model is ready for the design. In the next video I will show you how to design concrete elements, columns and beams based on any standards available in SAP. I'm using Australian standards, and also I will show you how to use shell design feature in SAP for design of a slab and walls based on Eurocode.